Speed ready. Yes, it's SDL, Secure Digital Life, coming at you from Warwick Studios over here in Rhode Island, which is not sunny, so I won't say that part. Today, we're going to continue our deep, grotesque mulling about in subnet masking, and I know you want to know about it, so stay tuned.
This is a Security Weekly production.
Welcome to Secure Digital Life. And you type in AAA porn or whatever it is you're typing in. I'm sorry. I was at a PG show.
And I'm really excited to be here.
I'm glad you're here because somebody needs to know what's going on.
That's right.
Okay, so now
somebody has to drink this.
I think it's another day. It's another episode.
Yeah, he's looking at the wrong camera.
You put my camera over here. Cut. Basically, forget you ever saw that. I think actually forgetting you ever saw that would really be a good idea at this point. August 8th. Yes, already it's August 8th. Summer is almost over. Doug is here. SDL. Russ is here to add a cool factor. Wow,
hi,
what's
everyone.
that kick in? Yeah, Russ is joining us today because he's going to do a demo because he's actually helpful, unlike me, who can usually do very little. DerbyCon is coming up, 2024 September in Louisville, Kentucky, which might be sunny. I don't know, but then apparently there's a derby there or something.
It's always sunny in Louis.
Yeah, something like that. Yeah. And the Wild West Hackin' Fest. We're going to be at the Wild West Hackin' Fest in Deadwood. Right now, if you're in Deadwood, Sturgis is going on. So that's a little bit of a different kind of feel, but in some ways kind of the same. But I know there's people that rode Harleys across the country to go to Sturgis this week. So.
I did not, but
I did not. Kind of I don't have a Harley.
I don't either.
Yeah, we don't have Harleys. But that's coming up 27th, 29th of October. It's actually 2 more days beyond that. There's training on the front end of it. So if you want some cheaper training than you can get elsewhere, check that out because it's actually cheap to go to Deadwood too. But they're running out of rooms at the lodge. And we've already decided that when they run out of rooms, we're going to keep just one room and let people fight in a pit to see who gets it for our amusement. Awesome. And we're all going to sit on a dais wearing togas and laughing and giving the thumbs up and the thumbs, or I did it backwards, the thumbs up and the thumbs down kind of thing.
Sounds good.
So that's coming up in October. So if you haven't planned to go, you really should gear up so you can be there in Deadwood. But now it's subnetting part D.
Part D.
Yeah, part D. And we're going to keep talking about this until you give in and surrender. But tomorrow I'm interviewing Congressman Langevin about cybersecurity. That's going to air actually on the 21st. So if you want to see that, because I'm going to go see the eclipse, so I won't actually.
Oh, are you really?
Yeah, I'm actually going to go see.
Where are you heading?
To Tennessee, because the eclipse is going right over there.
Right across
and, yeah, and so I'm going to go there and see the eclipse in Tennessee.
Make sure you buy legitimate glasses, not
I have steampunk welder glasses.
Awesome.
Yeah, that are actually super cool. So
take pictures.
Yeah, and I bought cheap Chinese glasses for everyone else. So when it does turn into the day of the Triffids and everybody's blind except me, I will be the king of the world. Let me tell you, because everybody else is going to stare at it through their cheap Chinese glasses. Yeah, I was reading about that too, and they were like, "Oh yeah, just because they say they're safe, that doesn't mean they're safe." And I was like, "Well, how do you test them?" And they're like, "Well, you could look at an eclipse." So we're going to pick somebody we don't like and let them look first.
I think you need a photometer and some sort of controlled light.
We're just going to go for it. I figured get a bunch of vodka and then just see, who'll look at it bare-eyed. Like, go for it, man!
Don't come back blind, all right?
Oh, it'd be interesting. But anyway, all right, so enough about that. So we're going to talk about subnetting now. I want to give you some review, again, because we've talked about this before. So one of the things, just to remind you of, is this is all Layer 3 stuff. And so when you're dealing with Layer 3 stuff, what you're dealing with is crossing network segments. So you're going from one physical network segment to another physical network segment as defined by the IP address and the subnet mask. And if you remember from last show, that the subnet mask is what ends up being used to determine where the network actually begins and ends. And we actually have terms for those things. So you'll see if you go out and you take these kind of classes that the network address is the first address in the segment. And the only way you can ever figure that out is using the subnet mask. And you're used to seeing it. And so you normally say, well, it's the 0 address. But that's not always true. Because if we have fixed link subnets, like we talked about last week, so you have a /24, a /16, a /8, then yes, it is the 0 address. But it's not always a 0 address, because if you start tweaking those subnet masks, things change and they become different. The end of it is called the broadcast address. So you probably heard people talk about that. The broadcast address is the last address in the segment. Where is that? Well, again, in those fixed link masks, it's pretty easy, and it's usually something with 255 in it. So you see on my piece of equipment back here behind me, that thing that Paul bought in Vegas, we don't know what it does yet, but he's going to hook it up to something, and we're going to turn it on and see. Yeah, I figure that probably satellites are going to fall in the studio or something when he turns it on. But I set that to 255, so we'll see what 255 hertz gets you, but probably something bad. Yeah. But the broadcast address is the last address in the sequence as determined by the subnet mask. So again, this is really a tricky business. And the broadcast address is then used to send to everyone. So if something is sent to the broadcast address, it is literally broadcast by layer 3 devices, and it goes to everybody in the network segment. The other term I was going to give you was CIDR, C-I-D-R. And CIDRs are essentially, there's a whole lot to CIDR. So if you're really into this, don't get mad, because I won't get into the whole thing. But for our purposes right here at the introductory level, CIDR is where you see somebody, instead of writing a subnet mask like 255, 255, 255, you'll see them just write slash and a number. So you see /24, /16, /8. And what that means is that's how many bits starting from the left are turned on in the subnet mask. So a /24 means you've got 24 bits starting from the left side. That's called a big Indian, by the way, spelled with an E. So nobody should be offended. It's from Gulliver's Travels, if you want to know. And that gives you the /24 subnet mask. And you see a lot of people writing those that way now. A lot of systems, a lot of network and layer 3 devices will accept subnet masks written as CIDRs instead of being written out in dotted decimal notation, which is that 4-segment junk. So let's talk a little bit about how this stuff actually works then, just to review. So if we took an example of 172.16.10.0, so this is an address, and I use a CIDR of /24. That means that there are 24 bits turned on starting from the left. So that's 255, 255, 255. We're going to do a real example where you can see it on the screen in a minute. And when we do that, that leaves the final octet. So that 0, the 10.0 piece, that's the last one. That whole octet then is host bits. And when we have host bits set up like that, that means that the network address, or the network, is .0. The broadcast address is the last address in that octet, which in that case is 255. So that's a pretty standard one that you see at home a lot, or you see even at work. You'll see those kind of networks. But if you start looking around, you're going to see all kinds of other things, particularly if you go out in the marketplace and you look at something like, if you want to check out the Cox address or your Verizon address, if you open up your home router and you look at the configuration, look at the WAN configuration. Don't mess with it, but look at the WAN configuration and look at what the subnet mask is there. At work, a lot of times, if you'll look at your subnet mask, it might be something interesting. Sometimes they don't like you to see those things, but if you type ipconfig/all, you'll actually see all that information on your screen, and who knows what you might learn from that. But that leads us to the topic of the day, which is variable length subnets. And this is, and I'm just sit down if you're not. I mean, just relax and maybe take a Xanax or something. No, don't do that. I am not a doctor. I just play one on TV. This is the single most dreaded topic in all the CERT classes. No kidding. So if you take any of these, CCNA, CCNP, any of that stuff, all those certs, people dread this beyond belief. The instructors dread it too, because it's a hard thing to teach. And basically, it's not that hard. It's just weird. And once you get used to it, it's actually not very bad at all. So you've seen us talk about these CIDRs of /8, 255.0.0.0, /16, 255.255.0.0, /24, 255, 255, 255.0. Those are fixed link subnets. But variable link subnets mean, what if you want to do something different? What if you want to just have a more unusual network? What if you don't have enough addresses? What if you have to do something, or you just like things being complicated like me? then you may indeed use variable length subnets. And you will start to see CIDRs of things like /28, or what about /23. And all those kind of setups work because in the spec, in the IEEE 802 spec, all this stuff is defined, and the layer 3 device only cares about the bits. It does not care about these ridiculous decimal numbers that pathetic humans have to use because they can't count to 2. Or 1. Yeah, start at 0 always. I mean, we're C programmers here. Thank you very much. None of that Java stuff for me. But basically what we want to do then is I want to let Russ sort of walk you through some examples. He built this awesome spreadsheet, which you can get on the wiki. And it's beautiful because all his spreadsheets are just like, you just sort of swoon when you see them.
Oh, stop.
It's like the Gauguin of spreadsheet design. It's so beautiful. But he built this really cool spreadsheet that we put on the wiki. So if you want a copy of it to play with or practice with, you have it. So I'm gonna let Russ show us his example on this. So we got the screen even, so you're going to see the whole thing right here. It's not just my beautiful face. It's actually Russ's. There it is. Look at that.
Yeah, yay.
Awesome.
So this spreadsheet, as Doug said, I built specifically for this particular workshop, if you will, or whatever you want to call it, recording. And it's sort of a cheat sheet that on the wiki you can download and print out if you like. Keep it by your little workstation. So what this is it talks about in the uppermost box here, talks about the different class of networks and what their public IP address range is from. And it also talks about what their default private IP address range is, and also this CIDR, or classless interdomain routing number, or mask. So in a Class A network, the public IP range would be from 1 to 126, and then you would have this default private IP range, and it would be a /8. That /8 indicates, starting with the first octet, the number of values that are turned on. So a /8 would mean that this bit is turned on, this is turned on, and on. That's 8 bits. So 1, 2, 3, 4, 5, 6, 7, 8. And if you add all of their values together, 128 plus 64 plus 32 plus 16 and so on, you get the magic number 255.
Yay.
Which is why the highest number of value in an 8-bit binary system would be 255.
Right, which is why we set it on the Hertz meter back here.
Right, which is why we set it on the Hertz meter. So a /8 mask means that this here, the first octet, is all of your network, and everything after that is a host. Okay? So your second octet, your third octet, and your fourth octet. Now, that would mean that your subnet could be 255.0.0.0. Okay? So that's the first. Now, in a Class B network, we start with public IP range 128. Now, notice that 127 is missing. That's in between 126 and 128 because we reserve 127 mostly for local host and things like that.
There's no place like home.
And there's no place like home. That's right. So we start with 128, and you should memorize these, by the way. That's just the way you do it.
Or learn them in binary like I showed you, and you can figure it out.
Yeah,
you don't have to memorize.
He's
I
right.
don't like to memorize.
He's right.
Do the math.
Do the math. So in a public IP range of a Class B network is 128 to 191, and the private IP by default looks like this. And this is a CIDR 16. So using the information I taught you with a CIDR /8, let's look at a CIDR /16. So 16 is divvied up into 2 times 8, right? So we already know that 1, 2, 3, 4, 5, 6, 7, 8. Those bits are all turned on. And then you're adding another 8. And since each octet is a series of 8 bits, oh boy, 8-bit, right, just like old school Nintendo, we're just going to add another 8 here and turn them on. So we have first octet all turned on, second octet all turned on. That's a /16 mask, which means that it's 255 dot, what is it? These are all 0. So in the /16, these would all be 0. Just like that. And then your final octet would be all zeros, just like that. Okay, pay no attention to the purple right now. So your subnet would be 255.255.0.0. Okay, and then finally, speeding up just a little bit more because I think you've got that concept down, is we move on from 190 to Class C, which is 192 to 223. These are the private IP range, and this would be a Class 24. Class 24 would be your first octet full, so that's 8. Second octet full, that's another 8, so that's 255.255. Your third octet would also be full, all turned on like this. So your default mask would be 255.255.255.0.
Yay.
Okay, yeah, and that's how we get to 0. And just to prove to you that that's the case, I'm going to show you my network address right now on the Wi-Fi here, and I'm running at TCP/IP. I'm running at 255.255.255.0, and that is, you know, that I'm on a Class C network because of that subnet. So that's the easy stuff. That's the default. That's the default masks. Okay. Now, Doug mentioned variable length masks. What do we do here?
My favorite.
What do we do here? Let's say that we have, or we're given on an exam or something like that, instead of an 8, a 16, a 24, let's say we're given a 22. Shoot. What do we do here? Okay. So we're given a /22 CIDR, and it wants us to find the network and where the network and hosts separate. Okay, so in actuality, it's quite simple. Okay, we always start at the leftmost number in the first octet. So break all of your octets down into the binary, like you see here, or so 128, 64, 32, 16, and so on and so forth. Okay, so write that down. I use Excel because I like the way it looks. You can use pen and paper if you want. So in the first octet, we're going to start, and we're going to count bits. So we're going to count out this number here. What's this number? 22. So we're going to count from the left to the right 22 times. So, and we're going to turn everything on. So this is 1 on, 2 on, 3 on, 4, 5, 6, 7, 8. Okay? That's because there's 8 bits in the first octet. 9, 10, 11, 12, 13, 14, 15, 16. 16 bits. Okay, I bet you can see what's coming here. 17, 18, 19, 20, 21, and 22. There it is. So we stop at 22. That is where the separation between network and host delineate. So everything else after that, turned off.
It's an abomination.
That's it. It's an abomination. So we now have this point here, which I'll flag. I'll color it yellow. Okay, and everything to the left of this is your network. Okay, so net. And then everything else after that is your host. Okay, so now we've just found where the differentiation between the network and host is, and then when we pick up maybe after another example next week, we can talk about how we figure out what those usable IP ranges are for the network and host. Let's do one more. What do you say? Do we have time for one more?
Sure.
One quick one? All right. Let's do a /18. So what does that look like?
I don't even think that's legal in a lot of states.
Let's pretend, yeah. So
this pre-version of
Okay. Now let me give you a little shortcut. Now that we've done one, since every octet is 8 bits, you can start by looking at so we can take 8 bits from this. So what's left? 10. Can we take another 8 from that evenly? Absolutely. So we already know that the first 2 octets are full. So we can just leave them as 1. Okay? So if we take 8 times 2 is 16 and subtract that from 18, how many are left? 2. So we know that in the third octet is where our action is going to be. And if there's only 2, then we know that the first 2 switches are turned on. The rest are 0 value. So that is what a /18 CIDR mask looks like. And then network ends here, host picks up here, and then continues on after that. So hopefully that solidifies things a little bit more.
I agree. And so I mean, you'll see these things given all the time. And I was going to bring up some Cisco examinations then about if you're taking CCNAs in plus, I don't know if did they cover us in in plus? Did you
I don't know, not
in plus.
Sec plus, but I'm not sure about the network.
We'll have to look at in plus. I don't know, but on CCNA and all these kind of these network certifications, they will give you problems like this, and they're the kind of problems that some of us like and some of us don't like, that people call story problems.
Yeah.
And so I wrote some examples in the wiki that you can see that are similar to this, but like one of them, this is a common one. You need to design design a network which has 10 networks and 30 hosts. And all this assumes that you have a restricted IP space. Now, remember, we talked about this before, that with the advent of IPv6 and the advent of NAT-PAT, and this is some other shows we've had, once NAT became a standard, it was possible for you to use these private addressing structures, 172.16, 10.0.0.0, 192.168, and essentially have a vast number, 2 to the 32nd minus 1 private addresses you can use. Now, there was a time when people were using this because they were running out of IP addresses to use in their networks, and it became a very, very critical exercise for network engineers to be able to do this. This has persisted, and I think part of it has just become a skill that people want you to have. Like in the old days, they used to have people, you had to learn how to use a slide rule. So like when I first went to college, there was a big deal about people knowing how to use a slide rule.
Yep.
Because it was just not because you needed it. It was just because, well, you don't know how to use a slide rule, do you, son? You know, and he's like, and that became a bit of a problem. Today, some of this, I think, is an artifact. I really do. But it is also a useful understanding of how network structures work. And here's the biggest reason you need to know it. I know you're saying, Doug's saying, these kids today, with their web calculators and their Python language and their Rubies and all this, don't know how to do binary subnet masking. Well, here's why you need to know. Because old geezers like me built these networks. And that means that you, nice and young as you are, standing on my virtual lawn, waiting to get blasted with my virtual shotgun.
Get off the lawn, kids.
Get off my virtual lawn, you little... But the problem you're going to have with that in the real world is that old geezers like me did build these things, and they remain as artifacts. And you're going to run into them when you go out there in the workplace, and all of a sudden you inherit a network, and they go, we don't know why it's like that, just don't touch it or it'll break. And I've picked those jobs up as consultants before where people were literally standing around going, this thing says /29. What does /29 mean? It's a pre-version. We're going to suffer the hellfire and damnation. And that becomes a problem. And the last one I'm going to tell you about today is this thing. Thank you, Travis. Travis was a student of mine a long, long time ago, not even in this state. It was in another whole region of the country, different time zones, all kinds of things. And Travis got obsessed with subnet masks. Mm-hmm. And he really, really got into it and started asking questions you wish students wouldn't ask. Like, you know, you're awfully cute, but but he asked me, what if you had a subnet mask that was something like 10101010? And I thought, wow, what an astute question.
Yeah.
And then I said, you fail. But it was a very astute question, because what if you had a subnet mask of 10101010? Yep. So that's 10 hex. The answer to that question is the layer 3 device wouldn't care. The layer 3 device would say, well, the ones are network bits and the zeros are host bits. And Travis became obsessed with this. And we started calling these Travis nets. And I still, to this day, when I teach networking, I still talk about Travis nets, because the Travis net is the point where you truly understand. You have become, yes, my son, a Zen master of subnetting, when you can actually derive subnet broadcast and network addresses for a Travis net. So instead of having something nice like a /24, what if you had some just whacked out number, you know, out there in that field? Would it work? Yes, it would. Does it make any sense? No. Will everybody in the company suffer and want you dead? Absolutely. But that's a really good reason to do it. And if you understand a Travis net, then you actually can, I think, really say you have mastered subnet masking, because that's where you can do this. It makes no sense, but the layer 3 device doesn't care. Yep. But your network's going to be I'm not supposed to say swear words on here, but it was really hard not to right there. It's going to be a blank, fill in whatever one you want, mess that you will hate and everyone around you will hate. But if you could do it on paper, it's a lot of fun. And you can certainly test it in Packet Tracer. So jump on Packet Tracer or GNS3 and test it out. We'll be back next week with more exciting subnet masking. Thanks, Russ, for being here.
Thank you, Doug.
You're too cool. And we'll see you then.